Okay, so let's look at another question that is pretty similar to the question that we just solved. And okay, an is the nth term of a geometric sequence where a1 equals to 10. So the first term would be 10. And another information is a1 3 times of a2 and 5 times of a3 is an arithmetic sequence. And the common ratio for this GS would be 0.2. So this is actually part A of the question, and the question only gave this up till here. But I solved A, which is the common ratio, and this is actually information for part A. So now let's take a look at part B. Let Bn be the nth term of another sequence, and Bn equals to log An. Find the least value of n such that B1 plus B2 plus B3 plus blah 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 plus Bn is smaller than negative 200. Okay, so this is actually, it looks pretty familiar, but it's actually pretty different. So if you take a look at here, we usually solve an, so we know what an is, and usually it's an arithmetic sequence, but right now it's in GS. It's not. It's a geometric sequence. So that's the first difference. The second difference would be that we usually put the log, the question would usually put the log on the other sequence, but this time we put the log here. So it actually changes a lot on how we approach this question. If you haven't forgotten what I taught you just now about that there is a hidden AS sequence when a GS is logged and becomes an AS. This question uses the similar technique. And let's quickly quickly solve this question. So, I'm a bit forgetful, but basically, I think, first of all, we have this question, and, Bn is log An. So the base is 10 because they didn't really specify, so it is log 10. This is the base 10 and An. So, what we have here is pretty nice. And let me just fill you in with some information first. So in part A, I found that the common ratio is 0.2, and actually, this is the first term, right? Because the GS sequence would be first term times common ratio with this little index right here. So this would be similar, and it would be like this. This would be the the formula for this question. Let's see here. Okay, so if we can fit it in, it would look like something like this. Oh, sorry, no. So it will look a lot like this. We just put these numbers into this equation and we can get this. And we can quickly just copy down this whole thing that was given to us down below so that we can see it clearly. And then what we're gonna do is we can substitute this down here because we have no information on B, but the only information is bn equals log an. So we can use a lot we can have a lot of information from this little piece of info. So we can just quickly sub it in. Yeah, so actually I don't have to put the big brackets. Okay, so this is the first term. So 1 minus 1 equals 0. So this will be 0, and anything with a 0 would be equals to 1. So it could be 6 to the it could be 6 to the power of 0 or 8 to the power of 0. It would still be 1. So it would be times 1. I don't actually have to write this, so I'll just delete that, and I'll just write log 10 plus log, okay, 10 times, so this is the second term, so 2 minus 1 equals 1, so like this, and so on. Okay, so I've copied down the whole equation. If you can take a look at here. This is the whole equation. Okay, so now, as I just mentioned, there is a hidden AS when a GS is logged and becomes log plus. The reason behind this, I will explain it again in case you forgot about it. So, if we have this is the common ratio. So that means that if a later term is divided to the previous term, it will be equal. It will be the same, no matter which later term you choose and which previous term you choose. It will be the same because they will all have the common ratio of 0.2. So one of the properties of log is that when you have log AB, it actually means that it's log A plus log B. And when you take a look at this, A divided by B, you actually have A minus log B, log A minus log B. So this is a sort of hidden information. It's like a properties of log. So when you take a look, if you fit in the numbers of A3, so for example, the second term would be 0.2. 2 minus 1 would be 1. So something like this. So when we are doing G2 divided by G1, you will have this, and see, it's 0.2. So it is the ratio. So when we are fitting in this property into this equation right here, we can see that, oh, log plus, which definitely means something. So, okay, sorry. No, sorry. Log plus, right? Okay, so it is log plus. That means it actually has a hidden meaning of log times. That means that it's log 10 times 2, 0.2 times blah, 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 blah. Okay, so it's actually a times equation, which means that since it itself is a GS, this must be an AS. So using this key information that we have, we can just quickly find out the new common ratio. And if you haven't forgotten from what we've learned just now, the common ratio, the common difference, the new common difference can easily be found by putting in log and the common ratio. So for this question, it would be 0.2, the common ratio. So this would be the new common difference. Okay, so now we have this, and it's a plus. So log 10 and log 10 times 0.2 and log this and this and this, they form an AS, right? But each AS term is adding up together. So this forms a sum of AS. And the equation for the sum of AS is the first term, which is A, plus the nth term minus 1 times the difference. And a quick reminder, what is A now? A is not it's not 10 anymore. No, it's not 10 anymore. But right now, for this AS equation, remember, we are looking at this new AS equation instead of the GS one. Yes. So this first term should be right here. Log 10 should be the first term. So according to this, we can just quickly plug in the numbers. If only I can find my pen. Yes. And then we can 10 plus n minus 1, and then we can plug it in, log 0.2. And then this would be smaller than negative 200, right? So when we have this, we can just quickly simplify this equation. We all know that log 10 equals to 1, basically. So 2 times 1. Oh, before that, we can just times it over here. And 2 plus 1 log 0.2. Oh, we can also press my calculator and check what log 0.2 is. Okay, so I'm definitely not writing this down. I'm just gonna use log 0.2 n. So remember, you put the n in front instead of at the back, because if you put it at the back, we will assume that, oh sorry, can't see it. If you put n at the back, it will mean that we are this thing. We're logging this thing. But if you put it at the front, it means that it is log 0.2 times n. So there's a big difference. And if you think it's too hard to understand, you can just plug in some numbers again. So for example, if n is 2 and n is 2. So the first one, which is putting n at the back, it means that 0.2 times 2. And then we log it. It will be negative 0.3979. And if we log, and for this one, if we put n at the front, it will actually mean log 0.2 times n, which is 2, and it's a different number. So it's negative 1.3979. So there's a huge difference. I hope you can see it. Yeah, so this is the first one, and this is the second one. First, second. So yeah, that's basically it. So you have to put it at the front, right here, and then you continue. And then we multiply n into the brackets. And then remember we have n2 because n times n. Don't really have much space right now. Okay, so then when we have this quadratic equation, we can just quickly press formula 1 and we will have this beautiful, beautiful answer. So hold on, before that, it's just to make it easier, we can see 2n, right? So you can just do this. Okay, it's okay if you don't know what I'm doing, but I'm just basically press the calculator. Press your calculator for formula 1 for this quadratic equation and solve it, and then you'll be good to go. So yeah, I'm just gonna do that right now. So the answer would be negative 22.0.1 and 25.9. Sorry. So these will be the answers. And so hold on. As you can see here, this is smaller than 0, which means that it's over here and it's connecting together. So it means that it is and. So when we get this information, we will have this answer. It should be correct because I checked it. Yeah, so basically this is how you do this type of question. I hope this video sort of helps. Yeah, thank you, bye.